So in front of you, you should have your packets open to the very first page. We are going to be looking at lesson 601 today, which is titled Modeling with Exponential Functions. So the goal for today's lesson, which by the way is a pretty short lesson, we should be able to finish it within the first hour. The goal is to apply logarithms, which we learned last unit, to be able to solve exponential functions like the ones that we will look at today. And all of the problems that we see today is going to be a word problem, so some sort of like real application. Okay. Now, before we dive into the lesson, we want to look at this warm-up. Now, if you read the warm-up, we have the following scenario. It says, Aladdin and the genie were chatting one day. The genie gave Aladdin the following options and said, I will grant you the option that you choose. So hopefully you're following along. Here is the first option that the genie gave Aladdin. The genie will give Aladdin $1,000 to start with, and then over the course of 10 days, he will give him $100 each day. Okay, so think about that, option A. I'll repeat it in case you guys were not listening. The genie will give Aladdin $1,000 to start, and then he will give Aladdin $100 each day for the course of 10 days. Or Aladdin has option B. The genie will put $3 in his lamp, and each day the amount will double. Aladdin will get the total amount of money from the lamp at the end of 10 days. So think about the similarities and differences between both options. With both options, you still have the same time frame. It's still 10 days. However, option A, you start with 1,000 and you get 100 each day, whereas option B, you start with 3 and that doubles over 10 days. So I see a lot of you guys doing calculations. Do not do any calculations yet. Just think about which option you would choose when presented with the following. Okay, just at a first impression, a first glance, what would you choose? So take a few seconds to think about that, and then we'll check in together. All right, so as I walked around the room right now, I heard a lot of people say A, and a lot of people say B. Who can give me one argument why you think A is a better option? Go ahead. Oh, so you're saying for B? So B would be better because you'd be making more money because it's doubling. In the end, okay. For those of you guys that picked A, why do you think A is better though? Go ahead. Yeah, you instantly start out with 1,000, right? So if we're comparing the amounts on day one, it's a lot more money off the start. Okay, so hopefully you guys have something. You can write something down for number one. But now what I want you to do is I want you to actually complete the tables. So you're going to now fill in option A and option B. Just for reference, this is what option A should look like. You're starting with 1,000, and it's increasing by 100 each day, right? You kind of get the idea. And then option B, starting off with 3, and it's doubling. Okay, so each box for option B, the one before, you're going to double it. You're going to multiply by 2. Okay, so go ahead and try that out. And once you have that, answer the questions at the bottom, and then we'll check out the table together. I mean, you should have it done already, but let's just check in. So with option A, you are going to add $100 until you hit a cap of how much? 2,000. So over the course of 10 days, you're starting off with 1,000, going all the way to 2,000. So at the end of that 10th day, you would have $2,000 with option A. With option B, let's see what happens. We start out with 3, 6, 12, 24, 48, 96. What comes next? 192, 384, 768, 1,536, and then 3,072. Okay, so if we are comparing the amounts on the 10th day, then which one can we see is obviously a lot more money? Option A or option B? Option B. So we can write that in for the question down here in the bottom. Which is better on day 10? Now, obviously on the 10th day and anything past the 10th day, you'd be making more money with option B. However, it may not be a great idea if you were to pull out your money on the 5th day, right? If you look at the amount of money on the 5th day, you're comparing $1,500 to $96. That's a big difference. It's not even $100, right? So we want to give credit where credit is due. Option A is a great option if you need money fast. If you have time, if you have days, then yeah, give it a try with option B and make sure you wait at least 10 days. Okay. All right, now let's try to write an equation that models the situation with option A. Obviously, there's a pattern, right? We start out with a set amount of money and we're adding a set amount of money. Now, that part that we're adding, is that a constant addition? Is it the same number that's being added each day, or does that fluctuate? It's constant. How much are we adding each day? We're adding 100. So that's a constant $100 that we're adding. Now, if we were to make an equation, this is how we would do it. Y equals your starting amount. We're starting with $1,000. Now, think about the operation that's going on. Are we multiplying 100 each day? No, we are adding 100 each day. So we would be adding 100. But this is where you need a second variable. Your second variable is going to represent the day. Day 1, day 2, day 3. And that's going to be represented by x. So we can represent option A with the equation 1000 plus 100x, where we are multiplying 100 and x because x represents the number of days. For example, on the third day, that would be an accumulation of $300. On the fifth day, it would be $500 extra. And then finally on the 10th day, $1,000 extra. Okay? All right. On the other hand, option B is also constant. It's constant growth, but are we adding by 2 every single day? What operation are we doing then? We're starting with 3, and to say something is doubling, what operation does it mean to double? Are we dividing by 2? What does it mean? We're multiplying by 2. So this is how we could express the second pattern. We start with y equals 3 is your starting value, and it's doubling. So it's being multiplied by 2. Now x, what do you think? Am I going to multiply by x? Is it 2 times x? No. It's 2 to the x power. Because x, which represents the number of days, would be represented by how many times 2 was multiplied by itself. Because it would be doubling, right? Now, we are going to use the equation for part B to try to answer part C. Now look what it says. For option B, how long would it take for the amount in the genie's lamp to reach $10,000? So what do we think about $10,000? Is $10,000 an input or an output in this situation? That's fourth period. Yeah. Yeah. So once again, think about the amount, $10,000. Is $10,000 an input or an output in this situation? It's an output. So we're going to set our function that we found in part B, we're going to set it equal to $10,000. Let's go ahead and take care of that. 3 times 2 to the x equals $10,000, like that. Now, hopefully this setup looks a little bit familiar because you just took a test on this. And I'm pretty sure this was part of your test at some point. So we should know how to solve this. Let's take a look. How do we solve this? To get x by itself, what would I need to do first? What would my first step need to be? I take the square root. What do? Do I turn this into a logarithm? Okay, I'm going to begin by dividing by 3 on both sides. So we get 10,000 over 3. X is not by itself yet, you guys. It is not by itself. I need to do one more step, which I hope you know how to do. Otherwise, I might have to go back and look at those tests, and everyone that got an A might have to retake it. I'm just kidding. But what would the next step be then? To get x by itself, I would need to convert this from exponential to what kind of form? Logarithmic. How do I turn this into a logarithm? Well, you begin by writing log, and then hopefully you know how to identify your base. What is your base in this scenario? Log base what? Log base 2 of 10,000 over 3. And all of this is equal to x. So this is your exact answer. Now, to find your approximate answer, you would need to put this in a calculator, which I know you guys don't have one in front of you. You'll get your calculators in just a second, so let me just do this one with you guys, or for you guys real quick. But you would do log, remember it's math, 2 arrows up, log base 2 of 10,000 divided by 3, which is 11.7. So approximately 11.7 days would need to pass by before you get exactly $10,000. Good? All right. So before we go into the guided notes, as you saw right now, we are going to need calculators. So send one person from your group to come and grab calculators up here, please. Thank you. Okay, let's look at some guided notes. So we're going to do some example problems, just 2 of them, and then you guys will get a chance to work on some with your group or with your new partners. So let's listen up. Anyone know where the town of Smallville comes from? Like the background of Smallville? It's like a fiction place. It's irrelevant, but anyway, supposedly like Smallville is where Superman grew up, right? Something like that. Yeah. Anyway, Superman. Okay, so let's look at the following. It says the town of Smallville is losing residents due to lack of jobs. The current population is 158,750, and it is decreasing by 2.16 each year. All right. So I highlighted, obviously you might not have a highlighter, so underline it. But there are some key words, key numbers to consider in this problem. Beginning with 158,750, that is your current population. The word decreasing is very important to us because it's going to tell us which operation we're going to use. And then the percentage 2.16%, we're going to use that as well. And lastly, the time frame, years, is also going to come in handy. Now, before you guys do anything else, we need to do a refresh on exponential growth and exponential decay, which we have learned about this in the past, but we have not applied it in a while. So write down the following. On the top of your paper, write down the following: exponential growth / decay. I'm going to give you guys the formula for it. The formula follows this structure. Y equals A, 1 plus or minus R to the power of T, where A represents your start value, your starting amount. R represents your rate, and T represents time. Okay? So hopefully you guys are able to see that. If not, I can zoom in. Once again, the equation for exponential growth or decay is the following. Y equals A, 1 plus or minus R to the power of T, where A represents your starting amount, R represents the rate, whether it be rate of growth or rate of decay, and T represents time. Okay? All right. So in this situation where we need to write an equation, are we going to use exponential growth or are we going to use exponential decay? And depending on your answer, I want you to tell me what word, what key word told you that we're using that function. So what do we think? Go ahead. Decay because of what? Decreasing. Very good. So we're going to use exponential decay because it's decreasing. So let's write that out. Y equals A, 1 minus R to the T power. And we're going to replace A, R, and T at this point. So Y equals A. What is your initial population? 158,750. I'm going to skip the commas. We shouldn't have any commas there. There we go. 158,750. 1 minus the rate. Now, here is the trick. The rate is a percentage, and I cannot combine whole numbers and percentages. The percentage, 2.16, needs to be converted to a decimal. To convert a percentage to a decimal, you are dividing by 100. What that means is you're moving your decimal place 2 times to the left. So 2.16% will become 0.0216. And then we don't have a time frame yet, so we're going to leave it as t. Okay. Okay. So that's our equation so far. We're going to use this equation to go ahead and solve part B. So let's jump into that section at this point. Y equals, we said it was 158,750. I am going to combine the stuff in the parentheses. 1 minus 0.0216 will become 0.9784. In case you're wondering where that number came from. Once again, it's just combining the 1 and the minus the number. Okay. We all good with that? Yeah. Okay. So we're going to raise all of this to the power of 5. So go ahead and try that in your calculator. Plug that in. 158,750 parentheses 0.9784 end parentheses arrow up and 5. Now you might get a number that has a decimal. So you should be rounding that number to the nearest what? To the nearest what? Not hundredth. It's not money. So we're not rounding to the nearest hundredth. We're talking about people. Can you have 0.7 of a person? No. Can you have 0.3 of a person? No, you can't have point of a person. You're going to round to the nearest whole number. Okay? All right. So who can tell me what the answer is then? Y is approximately how much? How many people would there be by the end of the 5th year? Go ahead, Kyle. 135,000. What is it? 157. Would the rest of you guys agree with this? This seems a little off. It's a little low. $142,330. What do we think about that answer? Okay. So most of you guys got that. Good. Very good. So maybe the decimal point or something was wrong there, Kyle. But yeah, the correct answer is 142,330 people. Okay, so it went down about 16,000 people. It's a lot of people to leave in 5 years. Okay, now we're going to get into the more complicated section of the notes. If the population continues to decrease at the same rate, how long will it take before the population reaches 100,000? So this number, 100,000, is an output. We're going to set that equal to our equation. So 100,000 equal to 158,750, parentheses 0.9784 to the power of t, like so. And our goal is to solve for t. It's to get t by itself. So think about the steps that we've done in the past. I know these numbers look terrifying because they're massive numbers, but the steps are going to be the same. Step 1, divide. We're going to divide both sides by 158,000. So we get 100,000 over 158,750. This is equal to 0.9784 to the power of t, which I'm hoping you can see that. It's written kind of small in the bottom. The next step, the second and final step, would be to do what? Am I taking the 0.9784 root of 100,000 over 158? No, I'm not. Yeah. Turn it into a logarithm. Very good. At this point, we convert this to a logarithm. T equals log base 0.9784 of 100,000 over 158,750. This is what you're plugging into your calculator. This stuff here in orange. So on your calculator, you're going to hit the math key and you're going to scroll up 2 times until you see the option for log base. And then everything else from that should be pretty straightforward. So math key, 2 arrows up until you see log base, 3 arrows up. Yeah. Enter. And then small box is 0.9784. Big box is 100,000 over 158,750. Now, because this is time, we are allowed to have decimals. So you're going to round to the nearest hundredth. Once again, because it's time, we are going to have decimals. If you're struggling, please call me over so that I can take a look. Okay, raising your hand, what do we get? What's the timeline here? It takes approximately how many years? Let me try someone who hasn't gone yet, but thank you for volunteering. Go ahead, Jason. 18.55 is a little off. Sophia? 21.16 is correct. So 21.16 years is approximately how long it would take to for this to happen, to get a population of 100,000. If you got something different than 21.16, double check that your operations are correct. Maybe you missed a 0 or something. Yeah. Okay, so any questions so far? As you can see, it's not necessarily hard. It's just a little long, but the process is straightforward. Let's look at a second problem, and then I'll have you guys work by yourselves. The second problem is the following. It says Jean buys a guitar that is signed by Justin Bieber, and she purchases a guitar for 10 grand. It's predicted to increase exponentially at a rate of 6% per year. Don't know how true this is, but we'll go with it. So let's highlight important information here. A guitar that is originally worth 10 grand is predicted to grow at a rate of 6% per year. So those are the key words. What I highlighted, 10,000, grow, 6% per year. That's going to let us know which function to use. What is this? Or is this going to be exponential growth or exponential decay? What do you guys think? Exponential growth. Why? Yes. It grows exponentially. It's right there, I guess. So it does say it's going to grow. So that means we're using y equals a 1 plus r to the power of t. So we get y equals $10,000. 1 plus, what will 6% become as a decimal? Point what? 0.06. So 1 plus 0.06 to the power of t. Using this equation, we can answer part B. Y equals 10,000, parentheses 1.06 to the power of 2. If you're at part B, plug that in. Plug that statement. 10,000, parentheses 1.06 squared. And round to the nearest hundredth, to the nearest cent, because this is money. Okay, this one you don't have to round. We get $11,236. So after 2 years, the guitar went from 10 grand to 11,236. Okay. When will the guitar be worth $15,000? So now $15,000 is an output. We set that equal to the equation. 15,000 equals 10,000. 1.06 to the t. We should be feeling comfortable with the first step. So let me call on someone. What would the first step be in this situation? Rafa, what would the first step need to be? Good, we're going to divide by 10,000 on both sides. So we get 15,000 over 10,000 equal to 1.06 to the t. What is this next step going to be? By now you've seen 3 problems, so you should know what the next step is. Jaden, what is the next step? Excellent, we turn this into a logarithm. Log base 1.06 of 15,000 over 10,000. So you're going to put that in your calculator. Log base of 1.06 parentheses 15,000 over 10,000. Once you have it, check your work with me. If you're rounding to the nearest hundredth, then it would take approximately 6.96 years, almost full 7 years, before the guitar goes from $10,000 to $15,000. Okay. All right. So overall, a decent return on investment, but not great, not optimal. Okay. So this pretty much wraps up, you guys, the section for the notes. The next section is a tutorial session or partner activity. What I'm going to have you guys do is you're going to work with a partner at your table, so just one other person. You're going to grab a whiteboard, grab a marker, and you're going to solve the problems and check in with me. Just lift up your whiteboard and I'll check your answers. All right, so go ahead and figure out who your partner is. Once you know that, grab the materials and get started.